All right, now I'm going to do a video on the chain rule. All right, so the chain rule is what you need when you have something that is the composition of two functions. Let me give you an example that's pretty straightforward, like this is number 5. I'll just write 5. This is number 5 from the homework. Here's a classic example where you have something like this as your function. Okay, and if they want you to do the derivative of that, you're going to have to use the chain rule. All right, see that function that you see right there really has two things going on. You're raising, let me not use letters right now, variables right now. So let's suppose this is our h function, and we want to know what was f and g so that the composition of f with g produces that. Okay, so the f function and the g function would be different things. When you're looking at that, you got to remember something about compositions for this to make sense. The input goes into the g function first, so that g of x comes out, and then that's what goes through this other function f. And that's what causes you to get that composition, that function within a function. Okay, so when you're looking at these, it helps to be able to, at a glance, tell what the functions are that would produce that. So see that 6x minus 11? That's the inner function. That's the g, okay? So g is doing 6 times your input minus 11. So if we're using an x, it would be 6x minus 11. Now see, f, you're not really going to put x in there. So let me use a different variable. This is what they do. They use like a u, and you see basically you're raising something to the 8th power. So that's your outer function. So your inner function does 6 times your input minus 11, and then your f function in this case raises that to the 8th power. So one of the ways of thinking about it is to do that, to let u equal 6x minus 11. Then you do the derivative by taking f prime of u and g prime of x, and then you replace the u when you get finished. So f prime of u would be 8u to the 7th, g prime of x would be 6, and then u is really 6x minus 11, all raised to the 7th power. Okay, and then you would put the 6 and the 8 together and say 48, 6x minus 11 raised to the 7th. Okay. All right, now what we did in class and what I would recommend is that you take some time to identify the inner and the outer. You do want to notice that, but then instead of using that approach, when you go to do y prime, if you're looking at something that looks like this, you can see basically the structure of a power function, something to the 8th power. You're going to bring the 8 down in front, have 6x minus 11 raised to the 7th, and then the only thing you got to do is tack on the derivative of the inside function. And you have it that quick. So usually I don't do those by using a u. Okay, but we could have substituted or thought of it using that formula. Okay. All right, so let's see. So let's do one that involves maybe some messy algebra, because I think that's where you're going to mess up more than anything else. All right, so let's see. How about number 13? That's pretty bad. All right, so that one had 5th root, and then on top it had 5x over 8x minus 3 all underneath that. Okay. All right, and that's your original function. All right, so it might help to think of it this way. Rewrite the 5th root as raising to the 1/5 power. So we've talked about that the denominator is the index. Okay. Then it kind of fits the structure of a power rule problem. So we'll bring the 1/5 down, take what's inside here, and then subtract. I said take the 1/5 down in front, take the 5x over 8x minus 3 and then subtract 1 from that, you'll get to where you can work better with fractions. You'll get to where you can tell that's -4/5, and that's all you'll write. Now, this is the hard part on this one, is you got to do the derivative of the inside function, and it's a quotient. But you can't not do it as a quotient function. So you do low times the derivative of the high minus the high times the derivative of the low, all of that over the low squared. Okay? So this one, that's it. That's the derivative. It's just not simplified yet. And this can be hard when you're first learning this kind of thing. All right, so one thing that might help is first, that's -4/5 right there. 1/5 minus 5/5 would be -4/5. And that -4/5 really applies to both of those. Okay, and this is times here. So you basically have just this going on. And that's on both top and bottom. This -4/5 is on both the top and the bottom. So I would probably next kind of think of it like that. I would have 5x raised to the -4/5. And then down here, I have a 5, this 5, and then the 8x minus 3 that's being raised to the -4/5. Okay. That 5x should be in parentheses on top. That whole thing is being raised to the -4/5. And that's a 5, not a 3. It just, my pen is not good. All right, then here we're going to clean that up a little bit. So let me show you here. That would be 40x. I'll go ahead and write it. So inside here I would have on top, I'm going to separate that into 2 as well. I would have 40x minus 15 minus 40x. And then the denominator I'm going to put down here with the other denominator. Okay. Because when you multiply fractions, you just multiply straight across. So that's what allows me to do that. Okay. So let's see, a couple things I might do at that point. For one, those would cancel out. For another, this means I got to move that to the denominator and make it positive. I'm not going to move this to the numerator, even though I could, because I've got that raised to the second and then this one raised to the -4/5. So I'm going to be able to add these two exponents together. Okay. All right. So some of those exponent rules you have to use, and you might not be able to do that very well at this point. Okay, something else I notice is 5 would go into -15 -3 times. Okay, so on top I have a -3. Okay, on the 5x to the -4/5, I would move down here and make 5x to the +4/5. Then these are being multiplied, and so I'm going to be able to add those exponents. So -4/5 plus 2 would be -4/5 plus 10/5, and -4 plus 10 would be 6/5. So the 8x minus 3 is being raised to the 6/5 power. And let me think. I think that's it. About as far as I can get on that one. Okay. All right, so that one was pretty messy. That's why I wanted to do it. So you could kind of get a sense of what to do and how far to go. Now, we could rewrite it as a radical, and normally I recommend that when you have radicals. But since one of these is raised to the 4/5, one to the 6/5, the raising to the 4th, raising to the 6th can be, you can do it, but you'd be allowed to leave it like that. So we'll just stop there. Okay. All right, so that one was one where you had a composition of functions and you had to wind up using the quotient rule. All right, let's look at this one, number 20. Okay, this one has y equals e raised to the 6x, and then 2x minus 1 raised to the 9th. Okay, so this one has multiplication here, both, and it's a product rule problem, but inside that, you're going to have to use the chain rule, because you see how you have 6x, not just x. See how here you have 2x minus 1. Okay, so look at this. Is a really good problem to kind of get your bearings. Make sure it makes sense to you. Okay, so first off, I'm noticing that this is a product. So when I go to do y prime, I'm going to have to take the derivative of the first. When I do the derivative of the first, okay, it's going to be e to the 6x, because that's how e's work. But then that was a composition of functions. I got to do the derivative of 6x, which is 6. So that's the derivative of the first times the second as is, plus the first as is, times the derivative of the second, which is a power function that has an inside function. So I'll do 9, 2x minus 1, subtract 1 from the 9 and get an 8. Let me expand my bracket a tad, because I gotta do the derivative of the inside. And the derivative of the inside is 2. So do you see how that was a combination of rules? I needed to use the product rule, but then each piece of this was the composition of two functions, and so was that. Okay, the inner function on this one was 6x. The inner function here was 2x minus 1. So that's why I had the 6 right there. That's why I had the 2. Okay. All right, so now look, there's a lot of stuff I can factor out of this, because you notice this e to the 6x is common. And notice some of those 2x minus 1s I could pull out. So I have a 2x minus 1 to the 9th, and here a 2x minus 1 to the 8th. So I'm going to pull out an e to the 6x along with 2x minus 1 to the 8th power. Okay, then we'll see what's left. So from this term, I would have a 6 left, together with one of the 2x minus 1s, because I only took out 8 of them. Then with this one, the e to the 6 came out, the 2x minus 1 to the 8th came out, so all that's left there is the 18. Okay, so that gets me to here. And then this, I can go through here and just multiply the 6 like I need to, combine that with the 18. So that would be 12x plus 12 plus 12. And then I guess maybe I could factor further, pull the 12 out of that, keep the e to the 6x, keep the 2x minus 1 to the 8th, and then I'd have an x plus 1 factor as well. All right, so they can be they're not, I don't find chain rule problems to be hard once you get the hang of it. But they can be hard to know when you're completely simplified. So I'm trying to show you this little idea of factoring out. See, that was common to both terms, because that can make it a little bit easier. Okay, when you're trying to simplify. All right, let's see. I think we need to do one with a trig function. So let's do, oh, this is a good one. This gets at another issue. Let's look at 23. So 23 is a product of two functions, and one of the two functions has an inside function. See how that's not just cosine x, it's cosine x squared. So if, on this one, we're actually being asked to find y double prime, but we would just find y prime first and then just do it again. Okay, so it's a product. So we do the derivative of the first, which is 1, times the second as is. Okay, so that 1 was the derivative of the first. Then the first as is times the derivative of the second. Now here's where the chain rule is going to come in. When we do the derivative of the second, derivative of cosine is negative sine. So you would do that. Then you do the derivative of the inside part, which is 2x. Okay. And so we wound up then with cosine, and be careful, this is cosine of x squared, not cosine squared x. That's very different. Okay. And then here we have a minus. Everything else is positive, so that'll be minus 2. And there's an x times an x, which would be x squared. And then we have the sine of x squared. Okay. That's y prime. Our job was to get y double prime. So that means we've got to keep going. This is number 23. We've got to keep going because they wanted y double prime. All right, so let's just go again. So now I'm going to do y double prime. Now that I got this simplified, you do that in a different color. Okay, so I have an outside function is cosine, the inside function is x squared. So the derivative of cosine is negative sine. So you do that. Okay, and then you do the derivative of the inside part, which is 2x. Okay, then I'm going to come over here and do the derivative of this part, and this part I'm going to have to use the product rule. This minus can get you in trouble, so make sure you put the minus in a big bracket here so you don't lose it. All right, so for this one, I'm going to do the product rule. So the derivative of the first would be 4x times the second as is, then plus the 2x squared, the first as is, times the derivative of the second. Let me put the derivatives in brackets. I'm trying to do that. Put this derivative in a bracket. And let me just do a parenthesis around that portion. Okay, that's better. All right, so the derivative, so we did derivative of the first times the second plus the first function as is, and then we got to do the derivative of the second, and this is where the chain rule comes in. The derivative of sine would be cosine. So you do cosine x squared, but then you have to multiply that by 2x. So what you see in the brackets would be the derivative of the sine of x squared. Okay, and remember that sine squared x means sine x all squared, and sine x squared really means sine like that. They should write it that way to make it clear. All right, so now let's see what we got. All right, I would probably, before I wound up trying to factor something out, I think I would just do a little bit. I would put this minus sine x squared times 2x. I would write it as minus 2x sine of x squared. Okay. All right, then here I'm going to be distributing the negative and cleaning these up when I need to. So this would be minus 4x sine of x squared. Then this minus times this would be minus. And then 2 times 2 would be 4. X squared times x would be x to the third. And then I would have the cosine of x squared. Okay, and then these have the same, see that same variable part? So negative 2x, negative 4x would be negative 6x sine of x squared minus, close the parenthesis, minus 4x to the third cosine of x squared. Okay, and so that would be your y double prime. Okay, so if you'll really work on your homework, I don't think you're going to think of the chain rule problems as being that complicated once you get the hang of it. You just need to see it, because reading the rule makes it sound hard. Okay. All right, and so we did 20, right? Yeah, good. And let's see if we want to do another one. Did that one. All right, that may be enough. Let me just do one more. Did we do number 4? Oh, maybe another trig function. Yeah, why don't we do number 4, another one with a trig function. So let's look at that one. Number 4 started out on my sheet as y equals tan of 2x to the third power. And I want to do y prime. So I'm looking at it and I'm seeing this inside function. Okay, I know tangent, and see how the 2x to the third is all inside? It's not something raised to the third. So be careful about how you interpret it. All right, so first I would think, when I do y prime, I would think, okay, what's the derivative of tangent? And that would be secant squared of your input. Okay, but then because that function, inside function, isn't just an x, I need to take the derivative of that. So that would get multiplied by the derivative of 2x to the third. So the 3 would come down and get multiplied by the 2, and then I'd have x to the second power. Okay, and be careful, the 2x to the third, the 6x squared can't be multiplied because that's secant of 2x to the third. That's really secant of 2x to the third, all being raised to the second power. So that 6x squared can't just be multiplied by that. This is function notation, so you have to watch that. So the 6x squared would be out in front, secant squared 2x raised to the third power. All right, so that is the chain rule. And so you're going to be working on those. And working through the homework and all that kind of thing. And then just let me know if you get stuck on some. Okay.